Welcome back, Chemistry 30. Today we're going to look at section MS 3.6, Organic Functional Groups. So the learning objective here, up to this point we were looking at alkanes, alkenes, alkynes, the benzene groups with the aromatic compounds. Here we look at some other organic compounds that depend upon their functional group. So if we look over here, we're going to look at various classes of organic compounds based on their functional groups. We'll look at halocarbons, which are also referred to as haloalkanes, alcohols, ethers, aldehydes, ketones, carboxylic acids, esters, and amines and amides. And also look at where are these used in real life. So we'll look at real life applications of them as well. So if you look down on this sheet, the term functional group is used to refer to parts of the organic molecules where reactions tend to happen. So early on we talked about that. How a molecule functions depends upon its functional group. So those are the areas that tend to undergo reactions. These functional groups undergo characteristic reactions, and at the same time is true for all other functional groups. Each kind of functional group often undergoes the same kinds of reactions in every molecule, regardless of the size or how complex it is. So it depends upon that function, that extra piece that's attached to it. Thus, the chemistry of an organic molecule is largely determined by the functional group it contains. So the chemistry of it, whether it undergoes reactions or not, depends upon that functional group. So in this next part, this 3.6, in your booklet, attached is a hand-in section in which we'll look at all of these items here. We'll look at the structure of them. So what does it look like? Nomenclature, how do you name it? What are some properties, such as is it polar, boiling point, etc.? And then applications, we'll look at some real-life applications and uses. Where is it used in real life? So the first group we'll go through, the halocarbons or haloalkynes. We'll look at that one first. We'll look at that one together, and then you'll be able to see what you need to do for the rest of it. All right, so the first group, the halocarbons. So again, if you look at this sheet and the following sheet, you'll see that there's basically four things we need to do. Look at the structure, nomenclature, properties, and then at the bottom applications. So we'll do this one together just to see how we do it. So right here, halocarbons. Basically can be distinguished from other groups because they contain halogens. So of course on your periodic table, those are the group 7A elements. So we're talking about good old fluorine, chlorine, bromine, and iodine. So those are the ones we're talking about there. So if we look at a few here, we could have a carbon. Now, if that carbon was attached to hydrogens, it would be methane, of course. But we could have, instead of hydrogens, be attached to chlorines like this. And of course, the lone pairs of electrons would be around each chlorine, like so. And this would be called trichloro. And of course, one carbon is methane. So you can see how the naming occurs there. So we could jump into the nomenclature here. So the prefixes fluoro, chloro, bromo, and iodo. Are used for naming. And of course, other things we should know here, if there are more than one type, alphabetical order is used. All right, so here we have 3 chlorines, trichloromethane. Another one we could have, and of course there's hundreds of these, we're only going over a few. Benzene ring, indicated by that circle in the middle, indicating alternating double and triple bonds. We have 1 chlorine in there, so chloro, and of course this is benzene, trichlorobenzene. Another one, I'm going to make a butane stem, or a butane section here, and we're going to put a fluorine there, a chlorine there, and then the rest of these are going to be just hydrogen to fill in the gaps. Okay, and this one would be called, so we can number it in various different ways here. So 1, 2, 3, 4. I could have named it the other way, but if I name it this way, I'm going to have the alphabetical order in place. So 2-chloro dash, and then at position number 3, we have fluoro, and of course 4 carbons. It's a butane. All right, so those are some of the structures. So you can see regular alkanes with a halogen atom attached to it. 1 or more of them, of course. And of course, naming, we use the prefixes bromo, iodo, etc. for each type of different halogen. Now, if we look at some other things here, look at properties. So we could look at boiling points, increase as the halogen changes from fluorine to chlorine, etc. And of course, what's happening is you're going down a group. This is due to increase number of electrons shifting and making temporary dipoles. So what we're affecting here is, of course, dispersion forces. Increased with molar mass because you're increasing the number of electrons, and of course those electrons can move around and form temporary dipoles. So you only need to find 1 property, and that would be good enough for each one of these when you do it. Application, if you can get at least 2 of them. So these haloalkanes tend to be used as solvents. They dissolve other things, cleaning agents, since they dissolve nonpolar solvents. So they become slightly polar due to the random electron movement, and of course they cause other nonpolar molecules to become temporary dipoles as well by those moving electrons. Another example, Teflon, which is polytetrafluoroethane. Say that quickly 5 times. Is a plastic often used in carpet. So newer carpets that you buy are made of this, and they tend to repel liquids. Back when I was growing up, if you spilt red wine on a white carpet, that carpet was finished. But now you notice that the liquid tends to stay on top and bubbles up, and it's easily wiped off. because of polytetrafluoroethane. So there's a high resistance to staining. And of course, part of what that looks like, you have long change of carbons that go on continuously with fluorines attached onto that. And of course, I could go around each fluorine and draw the remaining lone pairs on there and go from there. But there we go, folks. So if you could try to find at least 2 applications, at least 1 property, nomenclature as best you can, it's going to be fairly easy to find that, excuse me. And then structure, if you could find at least 3 of those, that would be good enough to go from there. Okay, so we've done this first one together. So see if you can go on and do the remaining ones. And of course, you can find these on Google. Just simply Google ethers, aldehydes. And of course, if you have access to a textbook, most textbooks often have this material in it in the organic chemistry section. But you should be able to Google most of this stuff and meet those requirements when filling out these sheets. All right, we'll see you again.